After a successful launch and orbit insertion of the James Webb Space Telescope, scientists now want to send a telescope beyond the orbit of Saturn. And there are some compelling reasons behind this ambitious project. The James Webb Space Telescope is the most advanced space telescope built to date, and it's been sent 1.5 million kilometers away from Earth to orbit the L2 point, which further orbits the Sun. L2, or the second Lagrange point, is an excellent place to achieve the goals set for this telescope. It's ideal for astronomy because a spacecraft is close enough to communicate with Earth and keep Sun, Earth, and Moon behind it for solar power. It provides an uninterrupted view of the cosmos. So although it's the farthest telescope scientists have deployed in space, it's still too close to the Sun to make observations of deep space objects. This is because the bright light from the Sun interferes with the near-Earth telescopes, making some targets outright impossible to observe. And this is where a telescope lying far away in the outer solar system can come to the rescue. Now you may be wondering, how can we send such a space telescope that far into the solar system? Sending the James Webb Space Telescope 1.5 million kilometers was a nail-biting task that involved hundreds of single-point failure items. So how do we accomplish sending a telescope more than 10 times this distance? Well, the solution to this problem lies in the distance itself. Even a tiny telescope lying between 10 to 100 times the distance between the Earth and the Sun can outperform mighty telescopes near our planet. Of course, we know that the strength of a telescope depends on its primary mirror. The bigger the primary mirror, the more powerful the space telescope. But the scientific strength of a telescope far from Earth would come mainly from its location, and not its size. So even if we put a small telescope around or beyond the orbit of Saturn, it solves our purpose. If the Earth receives 100 units of sunlight, Saturn, which lies 9.5 times the distance between Sun and Earth, receives just 1.1 units of sunlight compared to the Earth. Hence, it's really dark out there. Though small and simple as compared to telescopes like Hubble or Webb, a telescope at this distance can make some truly unique observations that are difficult to achieve from a vantage point near the Earth. In addition, such a telescope can have a mass of just 9 kilograms, enabling it to be carried on any mission to Saturn or beyond. And we have accomplished something like this before. For example, in the Cassini-Huygens missions, the Huygens probe that had a mass of 318 kilograms was sent along with the Cassini probe. Upon reaching Saturn's orbit, the Huygens probe separated from Cassini to land on Titan, Saturn's largest moon. A view of the solar system from an outside vantage point can provide a lot of information about the dust clouds surrounding the Sun. This can also help understand the makeup of dust in other star systems. The disk of dust in the plane of the planets reflects the Sun's light on Earth, creating a haze almost 100 to 1,000 times brighter than light from other galaxies, which in turn obscures views of the cosmos obtained with near-Earth telescopes. But a telescope outside this dust cloud stays in a much darker region, enabling it to measure the light coming from outside the solar system without any interference. And if we can have a correct measurement of the ambient light of the universe over a wide range of wavelengths, we can have insights into how matter condensed into the first stars and galaxies. Besides that, this telescope can also help test the existing models of the universe. In addition, it can employ the gravitational lensing effects of the Sun to make exciting discoveries. Gravitational lensing occurs when the gravitational field of a massive object distorts the light of objects present behind it, creating a magnified and distorted view of the background objects that are otherwise difficult to be seen. Gravitational lensing plays a crucial role in looking for rogue planets. These are free-floating planets that have been ejected from their planetary systems. Or maybe they were never a part of one. Astronomers believe that about 50 billion starless planets are wandering in our galaxy, and some of them might have conditions to support life, despite the absence of a star to orbit. Rogue planets make up an exciting class of exoplanets and are a hot research topic among astronomers. Although the idea of putting a telescope beyond Saturn's orbit seems to be ambitious, it is well within the technological reach of NASA and some other space agencies. Missions beyond the orbit of Mars are rare and expensive. In 2027, NASA will be sending the Dragonfly spacecraft to explore Titan. It's expected to reach Saturn's orbit in 2034, but building an advanced telescope from scratch and integrating it with the Dragonfly mission's timeline seems impossible. So even if this project is approved, we'll have to wait for more than a decade to see it become a reality. But in the meantime, we have 5 exciting new space telescopes to look forward to. They include LISA, LUVOIR, HAB-X, DARE, and the Nancy Grace Roman Telescope. We'll talk about them in detail in our upcoming videos. So what do you think about the plan of deploying a telescope beyond Saturn? Please share your thoughts in the comments section and subscribe to our channel for more.